Assalamu alaikum. This is day 8. I'm Muhammad Masood Ahmed, and we are going to discuss these three topics today. That is maintenance work quality, safety and maintenance tasks, and post maintenance testing. Let us start with the maintenance work quality. A good quality maintenance work leads to good results. So the advantages are reduction or elimination of unexpected failures, lower costs, better safety, and increased confidence in work performed. Good quality maintenance work can only be accurately measured after the specification of expectations. Uh, from this, we mean that we should first uh, gather about information about our expectations, so what we expect from this maintenance, and then we would be achieving those. Uh, Once the aim of maintenance work is clearly identified, steps such as those listed below can be useful in producing good quality maintenance work. Number one, limit perplexity. Often the request for maintenance is incomplete and inaccurate. So ensure the work's proper completeness and accuracy prior to taking concrete steps. Second, define goals. Goals should be set by the maintenance team and its supervisors. Ensure that the team clearly understands the objective for the maintenance work prior to its start. So goals should be identified and disseminated to all the team. So everyone knows what we are achieving, trying to achieve from this maintenance task. Number three, avoid unsafe practices. Do not permit temptation to minimize maintenance time by shortcutting prescribed safety procedures. Uh, all the maintenance work, they should be done according to the required procedures, which are already distributed to all the workers. So there should be no shortcut, because in shortcuts there may be some unsafe practices which would endanger uh, the health of the people who are working on the maintenance task. Do not overlook secondary damage. Uh, Ensure that less dramatic secondary problems are not overlooked, otherwise, they would be costly at a later stage. Secondary damage occurs when there is a primary damage. You see that this thing is not working correctly, and you are going for maintenance to that. But when that part is not working properly, it is damaging other parts. So the other parts which are damaged because of the primary part, that is called the secondary damage. The simplest example in this would be the timing belt in the car engine. If the timing belt is broken, almost all the engine parts are broken. So that is the secondary damage. The primary damage is the timing belt. So that is why it is recommended that 100,000 kilometers distance, if traveled by a car, the timing belt should be changed. But here in Pakistan, the problem is we have a lot of uh, parts available in the market which are not up to the standards, and the older part may be better than the newer one. Anyway, now you understand the secondary damage. Report as the maintenance work progresses. So report all relevant information that could be useful for performing similar task in future. So whatever task you are doing, that should be documented and then reported to the higher authorities. Thus, it should be saved for future use. That is very important. Do not use second-hand parts. Ensure that failed parts are not replaced with second-hand parts. Although we can use second-hand parts, but if their life, the remaining life is less, it means you would be doing this repair again in a very short time of period. So it is not recommended. You should have full life available to you unless it is having some special advantage. Number seven, reinstall with extra care. Due to various factors, the condition of some equipment, system parts, or materials may deteriorate with time. Thus, when new or required parts, materials are reinstalled, excessive force can damage other parts. Avoid introducing new failures while correcting the old ones. Uh, so care is needed when you are doing maintenance work, and especially in old equipment and old parts, because with the passage of time these parts deteriorate, and when they are weak, you can easily damage them. So these tasks should be handled with extra care. Number eight, follow a system approach to box up. There is tendency to close up quickly after finishing a repair. After the repair, it is important to consider the following factors. Check for safety, ensure that all hotkeys are returned to appropriate places and involved persons accounted for. Uh, Check for all repair tools, equipment used. Do not restart in the event of missing item. So that is very important that usually when we are going to finish or the work is just finished, we become hasty. We want to restart the equipment very quickly. But before restarting, proper procedures should be followed. All the personnel, if 10 people are working, you should count all those 10. There may be places where you who can enter into the equipment. So there should be no one absent from that scene. And second, you are using tools, so all the tools should be collected and uh, counted so that there is no missing tool, because if the tool is missing, that would be in the equipment. And if the equipment starts, that can damage uh, your equipment again. So proper procedure should be followed, and safety uh, should be followed, and the parts, tools which you have used, they should be properly checked. Number nine, test the repaired item prior to its handback. Uh, the repair team or the maintenance team, they would have to hand over the equipment back to the production team, but before handing it over to the production team, it should be checked for its performance, uh, because there may be some tasks still left, so it should be ensured that uh, all the tasks are performed and it is able to work, because when the production team would be handling it, they would be hiring people to work on this machine, and if this machine is not working, then there would be loss. Next, complete all appropriate job records. Tasks such as equipment maintenance planning and failure analysis rely heavily on effective maintenance history. So all the records should be mm, used. There should be all the tasks should be recorded. Next is the maintenance safety. Safety and maintenance tasks. In addition to general safety considerations, other factors that influence the safety dimensions of maintenance tasks include numerous maintenance tasks or jobs are in direct response to the need of working safely. Consequently, safety needs augment maintenance tasks or jobs. And second, numerous maintenance tasks or jobs are hazardous and lead to hazardous solutions. Thus, maintenance work is a case of safety related problems. We have identified two things where safety may be compromised. One, that is the maintenance task is due to the compromised safety. And second, when we are doing the maintenance job, it can lead to hazards. So in both cases, we would be doing maintenance. So they should be done with care. The first item may be interpreted as one result of an effective safety management system. However, the second item requires further review. Some aspects of maintenance work that make the maintenance work unsafe are as follows. Number one, numerous maintenance tasks occur infrequently. For example, machinery failures, thus fewer opportunities to discern safety related problems and to introduce remedial measures. Uh, Usually, uh, the equipment failure, the main equipment failure is not very common. So we are not very used to it. Uh, in that case, we may make mistakes. So those mistakes can lead to hazards. So we should have these things documented. So before going for the maintenance, uh, we can read those documents. What are the uh, safety measures we should take and what are the steps we should follow. So this way we can easily decrease the number of safety related accidents. Uh, this can be uh, explained by the uh, Eid Namaz. In the Eid Namaz, usually the Khatib tells the people how to have their niyat. So they tell the audience there that this is how you should have your niyat. This is because the Eid prayer comes after almost a year, or only twice a year. So people may forget that. So the tasks which are infrequent, uh, they are prone to hazards. Second, maintenance work performed in unfamiliar surroundings means that hazards such as uh, rusted handrails, broken lights fittings, and missing gratings may pass unnoticed. So there are some cases in which we can make uh, errors, and what are they? Unfamiliar surroundings. When you go to some place for maintenance and that place is not very well known to you, uh, what can be that? Rusted handrails. That is, usually we have ladders or something on which we can climb and having handrails to hold on. If that uh, handle is rusted and dangerous for uh, touching, and you touch it, you can get injured. Broken lights fittings, that is, the light is not proper, and if the light is not proper, you can make mistake because of poor visibility. And missing gratings, gratings are the uh, gates or uh, guards, which prevents unintentional contact. Uh, if you remove the grating, then you can uh, touch or do whatever uh, process you want to do on your equipment. But that should be intentional, not unintentional. So that is why we use gratings. And if there is no grating, it means it is not dangerous, and that grating may have been removed by uh, some people for some purpose, and you did not notice it, and you can get injured. Number three, difficulty in maintaining regular communication with workers in some maintenance tasks. In some maintenance tasks, you would have to mm, have contact, uh, visual contact, or verbal contact with your fellow workers. And if somehow that contact is not available, you may do some mistake and get into problem. Some maintenance work may require performing tasks such as disassembly of corroded parts or man-handled handling cumbersome heavy parts in poor lit areas and confined spaces. Poor lit areas, clear from the uh, words that the lighting is not proper and you can make a mistake because of poor lighting. The second thing is the confined spaces. Confined spaces is a name given to those spaces which can be hazardous to enter, like tanks or uh, tubes, pipes, where you may have to enter for maintenance, and there you may have some toxic gases, some toxic liquids, or uh, problem of oxygen flow. So these are confined spaces. You can enter those spaces with safety permit. So some maintenance work performed required tasks such as disassembly of corroded parts. So corroded parts may break, and if they break, they can lead to hazards. Uh, Cumbersome heavy parts when they are to be moved, uh, there is always a danger of their falling on somebody. So you should be careful about that as well. Number five, disassembling previously working machinery, thus working under the risk of releasing stored energy. Of course, when you would be doing maintenance task, it means that machinery was running previously, and there can be some stored energy, like uh, you may have high pressure gas, high pressure liquid. If you open that, gas or liquid may release and endanger the workers. Uh, this can be a spring. A spring is loaded, and when you open suddenly, the spring force throws those parts at you. Or it can be some part which is rotating due to gravity, moving up or down or rotating. And when you open it suddenly, due to gravity, it starts moving. So it has stored energy. So before opening such equipment, you should ensure that there is no stored energy. In electrical equipment, these capacitors store energy. So the capacitors should be discharged. Sudden need for maintenance work, allowing limited time to prepare. That is also a problem. That is, uh, you don't want your equipment to be uh, down. So whenever there is a need for maintenance, you are rushed to the working site. You did not have enough time to prepare yourself. So, due to limitation of time, you want to conduct that work quickly and you get into trouble. Performance of maintenance work inside or underneath machines such as air ducts, pressure vessels, and large rotating machines. So, uh, these tasks that is working underneath the machine or in an air duct or a pressure vessel or a large rotating machine, it can lead to hazards. So, whenever uh, work on uh, parts like these is to be performed, extra care should be taken. Performance of maintenance work at odd hours in remote locations and in small numbers. Odd hours mean that uh, if the workers are working from 9 to 5, and at 4 o'clock they are told that they have to work for maintenance team. They are already exhausted and they have to do more work. So the exhausted people don't have that high concentration, so they can make uh, some mistake and safety may be compromised. In remote locations, that is, they travel to some far away location and they get tired in the traveling, and when they reach there they are guided to the equipment and they expect it should be worked on as soon as possible. So an error can be made. And in small numbers, that is, the work is for 10 people and 4 or 6 people are working on that. So, they may compromise safety and hazard can occur. Number nine, need to transfer heavy, bulky materials from a warehouse to the maintenance workplace, sometimes using lifting and transport equipment well outside a strict maintenance regime. Uh, Usually, when a maintenance task is performed, the other workers are not available. So, sometimes this transfer of heavy materials from the warehouse to the maintenance place uh, may be done by the maintenance workers, which is not their job. This job may be of some other team, but that team is not available. So the maintenance people are doing their job, and as this is not their routine work, so they may overlook some safety measure and endanger himself and other people. So there are some guidelines for equipment designers to improve safety and maintenance. So this would be uh, done. That is, the safety would be introduced into the equipment design. That uh, whenever a maintenance task is performed on that equipment, it would be safe. So the equipment is designed such that you cannot do it wrong. So one way to improve maintenance safety is to minimize the need for maintenance in systems or equipment at design stage. If the need for maintenance cannot be eliminated, the designers should follow guidelines for improving maintenance safety as follows. So these are guidelines for the designers. Simplify the design as much as possible. It should be a simple design. Complexity generally adds to maintenance problems. Second, provide fail-safe design to prevent injury or damage in the event of a failure. Whenever there is a failure, uh, it should be safe. Like we have a belt guard on belt drives, because if the belt is broken, that belt would be thrown at high velocity on workers. So it should be inside a cage guard, belt guard, so that it is not thrown. So similarly, other parts which can fly uh, after failure, they should be having guards. Number three, develop designs or procedures to minimize the occurrence of maintenance errors. We can do errors in maintenance as well. Uh, Attach parts incorrectly. So mm, there should be designs which not allow the parts attachment when they are not properly aligned. Number four, minimize or eliminate the need for special tool or equipment. Sometimes we need special tool or equipment for a task, and that is not available. Then we are doing some, we call it in Urdu a jugaad. We use some other uh, tool and try to do that task. uh, when we are doing it with tools which are not recommended, then a hazard can occur. Incorporate devices or other measures to permit early detection or prediction of potential failures so that maintenance can be carried out prior to actual failure with somewhat lower risk of hazards. Uh, I mm, have done maintenance on CNG equipment, and there we have temperature indicators, pressure indicators, and we have uh, voltage indicators and uh, ampere indicators. These things do help whenever the equipment is in problem. These readings get out of the uh, routine readings, so we can easily detect upcoming failure. So we can act before a failure occurs. This can be called as predictive maintenance. So when we can predict a failure earlier than the failure actually occurs, we can uh, do that maintenance early and make this safe. Number six, design for easy accessibility so that items or units requiring maintenance are not difficult to remove, replace, service, or check. Accessibility. We have discussed these things. If the accessibility in the equipment is improved, it would require less time for maintenance. Not only less time, but also it would be safe because uh, we can remove, replace, or service these parts easily. So, better accessibility would be a safe design. Develop the design in such a way to reduce the probability of maintenance workers being injured by electric shock, contact with hot surfaces, escaping high pressure gases, etc. These things are known to us, that is, where the electrical currents are high, where the hot surfaces are, and where high pressure gas can get out. So these places should be having special guards, and everyone should know that you are not allowed to go near these spaces unless required. So, if they are guarded, or the chances of accessibility to those parts is reduced, the hazards would be reduced. Eliminate the opportunity to perform maintenance or adjustments close to hazardous operating equipment or parts. So whenever we are doing maintenance, it should be away from those hazardous operating equipment or parts. Number nine, provide guards against moving parts and interlocks to block access to hazardous locations. Guards should be there, as we have discussed the bed guard. Interlocks should be there. Interlocks are uh, such locks that allow only uh, intentional movement, intentional uh, contact with the equipment. If you are not trying to tackle that equipment, then you cannot enter. It should be a mm, intentional act to touch that. So provide guards against moving parts, internet locks to block access to hazardous locations. These are the, guidelines for designers, and there is some human behavior, expected human behavior. So a list is provided. We can guide uh, or design the equipment using these human behaviors. So humans tend to use their hands first to test or examine. We need usually to touch, and if the touch is with hot surface or high voltage, that is not recommended. But people usually try to touch. Uh, you may have seen people moving along a corridor, they are touching walls, moving along a car, they touch its body. So that is a problem. Humans usually continue to use faulty items, equipment, or system. If the equipment is working, humans expect that it would be working further, and they continue using it, although they know that it is faulty and it can fail anytime. Humans tend to think of manufactured items as being safe. They consider that if someone has worked on it, so it would be safe. Humans are easily confused by unfamiliar items. When humans are introduced into an environment which is new to him, he would get confused. Humans frequently overestimate bulky weight and underestimate compact weight. That is, some mm, part or something would be bulky, looking big, but that would be not heavy. So they would be considering it as heavy. And sometimes there would be a part which would they think that it would not have that much weight, and that is heavy. So that can be a problem. Humans often overestimate speed of an accelerating object and underestimate speed of decelerating object. So when this can be seen on the road as well. Uh, Sometimes, especially in daylight, you can uh, estimate the speed of a car coming from the opposite side, but in the night that is difficult. So even when it is coming from the opposite side, if it is accelerating, you are not expecting it to be reaching you very quickly, but as it is accelerating, it may reach very quickly to you. And decelerating, and that is, you are expecting it to be stopping before it reaches you, and it is decelerating slowly, and it may reach you with some velocity. Next is humans frequently overestimate the probability of occurrence of a pleasant event and underestimate the probability of occurrence of the unpleasant event. Mostly when we are finishing a job, we are excited and we are saying that it is just finishing in half an hour, although it may take 1 or 2 hours further because of mm, uh, the nature of the part or sometimes you have to do some testing on that. Humans generally know very little about their physical limitations. Usually, people overestimate their capabilities. Sometimes, some people with vision impairment, they think that their vision is not that much impaired, although that is impaired. Sometimes some visual tricks happen and they get into trouble. So humans have their uh, limitations, so that should also be taken care of. I should start this after a while and stop recording at this point.